In this video, we are going to explain the required practical testing sheets of materials as insulators. We are going to test how effective various insulators are in slowing down the temperature change of hot water in a container. As we know, a material can be either a conductor or an insulator. A conductor is a material which transfers heat easily. For example, gold, silver, copper, or any metal. That's why metal is used to make the equipment used for cooking. An insulator is a material which slows the transfer of heat. For example, wood, plastic, and wool. This is why wool is used to make winter clothes. Now for the experiment. We will be investigating the effectiveness of different materials as thermal insulators. But safety first. We should always wear eye goggles in case hot water splashes, and we should handle hot containers carefully when moving them from one place to another. For the experiment, we're going to use beakers, cylinders, thermometers, lids, kettle, rubber bands, stopwatch, red wool, bubble wrap, corrugated cardboard, and aluminium foil. Welcome to our lab. First, we will prepare 5 beakers and boil the water using the kettle. We're gonna leave the first beaker unwrapped. For the rest, we will use bubble wrap, foil, red wool, and corrugated cardboard. And we will secure each with a rubber band around the beaker. Then we're gonna pour a specific volume of hot water into the cylinder, as well as into the beakers. We will make a hole in each lid to insert the thermometer. Now we put the lid on and record the initial temperature. We will start the stopwatch and record the readings of the initial temperature at every 5 minutes for 10 minutes. We're going to repeat for the rest of the beakers and try to get the same initial temperature and equal volume of water for more precision. And then we're going to draw a table to record our readings, just like this one. And we can plot a cooling curve for different insulators with the temperature on the y-axis and the time on the x-axis. Remember that water cools down slowly with the most effective insulator. So the upper curve represents the most effective insulator material, and the curve at the bottom represents the least effective insulator material.